Virgin Hyperloop to give us an insider's view on the company's plans to disrupt futuristic transportation dreams around the world. Please put your hands together for NPR's Jim Motavalli and the co-founder and chief technology officer of Virgin Hyperloop, Josh Giegel.
Well, here we are, Josh. We're talking about Virgin Hyperloop 1, and you're getting ready, you're getting close to your first project. Your project in India is the furthest along. Tell us about that.
So in India, we're trying to connect two cities within the state. So Mumbai to the city of Pune. That's about 120 kilometers away, and right now they are trying to, I'll say they commute between those two places in a car or a train. Sometimes it takes 5 hours or more. We can do that in about 25 minutes. And so we're looking at being able to connect these two super large population centers and move 150 million passengers a year, and should be breaking ground at the beginning of next year.
I saw you were quoted recently as saying this is going to happen in years, not decades. So when are we going to see the first Hyperloop open?
So we are on track for getting this product that we're building certified by roughly 2023. 2024 is what we're targeting right now. That really unlocks the next level of project finance. And so really after that, it's about how fast you can build. So we think, roughly speaking, you'll look at some of the first routes around the 2027, 2028 type of time frame. So, but I think it's pretty exciting from a point of view that 4.5 years ago we were sitting in a garage, we didn't have a prototype built, didn't have a couple of years of testing under our belt. And if you look at what's going on in commercial space, right, these companies trying to put astronauts who've taken 18 years to go from a garage to astronauts, we're trying to go a garage to grandmas in a little more than 10.
Wasn't it 2013 that Elon Musk wrote this thing on a napkin, basically?
Yeah, he talked about basically the idea of moving people inside of a tube. And while what he proposed on a technical point of view, we've actually made quite a bit better and really done a different piece of technology. But what he tapped on was this latent idea that people are tired of the old, boring, difficult ways to get around. And I think what we're trying to do is say, well, you see all this progress, you see all the progress here with companies that are just making changes, but we're still talking about new technology in transportation that's 1950s era trains.
And we're looking at, essentially, it's magnetic levitation. I know you're an engineer, and you have to be an entrepreneur in what you're doing now, but your background is an engineer. And what we're talking about is essentially magnetic levitation inside a vacuum, so there's no friction. Mm-hmm. And you can move something like 600 miles an hour or 500 miles an hour. And you've made improvements from what Elon did, and that it changes the way the car rides, is that right?
Yeah. So there's a couple of different ways you could build a Hyperloop system. So if I use the analogy of a road and a car, a road's very dumb and a car can be very smart. Same road that a Model S can drive on, a Model T could drive on, and it's very, very linear infrastructure. But for us, for trains, you see the power lines over top, or you see for the current maglev systems, you see a motor that goes along the whole length of the track. That's just a really, really expensive way to actually build a transportation system. And so what we've done is we've taken this idea of making the road, or in our case the tube, very dumb, and the pod very smart. And so the tube can last for a long time, 100 years, and you can upgrade pods with new technology as it comes along. And so to do that, our magnetic levitation technology that we were able to develop in the last 2 years is something that didn't exist even 5 or 6 years ago because of rare earth permanent magnets, because of controls, because of batteries, because of basically control algorithms, and all these different things that allow us to ride about an inch off the ground, but far more stably than a couple of millimeters like some of the old ones.
I've seen statistics that standard magnetic levitation, which we've had in China, and I believe there have been some movement in Germany on that technology, costs $100 million a mile to put in. You're looking at substantially less than that,
Substantially less. We just talked about a route in, so we have a number of projects. India is the furthest along. In Missouri, where one of our projects in the U.S. is, between Kansas City and St. Louis, about 400 kilometers. we looked at high-speed rail versus a Hyperloop on that. And so we came out on the exact same corridor. We could go 2 times faster, so a 4-hour car trip, now 30 minutes, for roughly the cost of half a tank of gas, far less energy consumption, and about 30% less than high-speed rail would cost for the same route. So far less than 100 million, closer to something like 20 million a kilometer.
Oh, that would seem to me to speed it along. And you're looking at, you can either embed these things in the ground or put them above ground. Are you mostly looking at the above ground solution?
Mostly above ground. We're trying to connect city centers. The sweet spot for Hyperloop is about 50 to about 1,500 kilometers. Anything less, you're probably taking public transportation, cars, autonomous buses. Anything more, you'll take a plane, a supersonic plane, whatever it might be. And so in that range, what you're going to see is basically, if we're going from here to Montreal, most of that will probably be above ground because there's not a ton of population along the way. But once you get into the city centers, coming into downtown Toronto, you're most likely going to have to go underground to be able to access that and have a really
If you put it above ground like that, does that enable you to be sort of above the infrastructure so it's easier to get the right-of-ways and that kind of thing?
Exactly. So we have a test site in Las Vegas where about two and a half years ago we built a 500-meter long, 3.3-meter diameter tube to test this entire prototype out. And with that, it's all elevated, right? So water can go underneath, you have animals go underneath, and you can go, in the case of Missouri, in the case of India, we're actually going along a highway right-of-way. So we're going speeds close to an aircraft because we can bank like an aircraft, but we're doing it along a highway right-of-way.
I understand these things will not have windows, because if you look out a window at 600 miles an hour, you're going to get awfully car sick. So take us inside the pod. What's it like for the passenger in there? Are we talking mostly single-person pods or more like 2 or 4-person pods?
We're looking at about 25-person pods. Anything more and you start to have a train, like a full-size train. A train holds maybe 600 or 1,000 people. And anything less, you really aren't getting some of the energy efficiency benefits that you'd like to have. And so this idea of having 25 people is, if we look at the corridor here, Toronto, Montreal, Ottawa, and we say, if I leave here and I want to go to Montreal or I want to go to Ottawa, I get in a pod with about 24 other people. Maybe it takes 1 to 3 minutes to fill up in rush hour. Maybe it takes 5 minutes to fill up in off-peak. We go and everybody kind of comes in a line. They convoy together. They're not actually coupled, but they go and they're basically like a truck convoy or a bunch of cyclists going together. And then when the group going to get off at Montreal gets off, they just pull off at an exit ramp. Nothing has to move, nothing has to switch, just like a bunch of cars on a highway. And when they continue on to Ottawa or beyond, that's really where they're able to, just come to I'll say direct to your destination without not like a train stopping at every single stop along the way.
I think when we talked before, you made the analogy to airplane travel, where it doesn't feel like you're going 600 miles an hour.
Yeah.
And so it'll be like that?
So once you get in, you'll get in with you and 24 of your friends, and you'll sit down, you'll feel what sort of feels like an aircraft to take off, so that feeling of about 0.25 Gs. Then once you're off the runway in an airplane, you really don't feel that acceleration very much anymore. So that's the same thing that you'll feel here. The benefit is there'll be no turbulence, right? There's no air, there's nothing, any bumps or anything like that will be taken out by the suspension system that we developed. And then when you come to the final stop, it's like an aircraft slowing down, and then it's like the aircraft on the runway. So imagine basically a super smooth experience where I dare say you'd be able to hold your martini glass in your hand and not have it tip over.
Like driving in a Rolls Royce.
Like driving a Rolls Royce.
And your test tube, you could call it that, I guess, in Las Vegas is like it's called the Dev Loop.
Yep.
So how fast can you go in that? It's not that long.
Yeah, so 500 meters long, but we went 240 miles an hour, about 400 kilometers an hour. So that's like everybody measures cars in 0 to 60 time, and a really fast car can do 0 to 60 miles an hour in 3 seconds. We did it in 1. So, but again, we want people, I like to say Hyperloop is kid-friendly, grandma-friendly, and vomit-free. No one's going to get on that if you're having to do this and having these really heavy G loads all the time. So keeping it comfortable for people is what we're after.
Just in terms of operating it, I would think there'd be less maintenance on these because there's not much friction. There's nothing that's wearing the pod out.
So it's nice seeing a couple different companies out here because what we're developing is what I like to call a solid-state vehicle. So there's actually no moving parts on the vehicle except for the doors. And so this idea of having everything controlled electromagnetically or electrically, and the ability for, I'll say, that to be highly simplified, highly controlled, is actually pretty easy for us.
When I knew you were serious about that was when I read that you've raised $400 million or close to that for this. Where are your other projects besides the one in India, and how far are they along?
So in the last, well, really what happened after we did this prototype in Vegas about 2 years ago now, everybody stopped saying like, hey, is this possible? It's more like, when will I see it? When can I ride it? Is the question that everybody's asking now. And so all of a sudden, all of these projects picked up. And in the US, the 4 projects that really picked up the fastest were in Colorado, so north to south, from Cheyenne, Wyoming, down to Colorado Springs, in Missouri from Kansas City to St. Louis, in Texas from Dallas to Fort Worth, and in the Midwest from Pittsburgh, Columbus to Chicago. And the one thing that's really interesting when you think about that is like something like Kansas City to St. Louis, which right now is a 4-hour car ride apart, connecting in 30 minutes, major hubs of the center with the university in between that there would be a station at. You can connect all of Missouri, the major populations of center of Missouri, faster than you can get across uptown Manhattan. And so if you think about what that does from an economic point of view, what you think about what it does from a connectivity point of view, like now you have regional powerhouses that can be on par with coastal cities in the US or otherwhere.
If you go back a decade or so, I would say the prevailing technology was probably high-speed rail.
Okay.
And the same sort of networks you're talking about across the U.S. were proposed as high-speed rail corridors. And essentially the funding for that never came through. So we don't have any high-speed rail corridors, and a number of the projects have just recently been canceled. Do you think that was just too expensive? I mean, is it not as, the technology isn't as far advanced as Hyperloop?
I think it's a couple things. One, why spend billions of dollars on something that's actually slower than another mode of transportation to get you there? I think that's probably one area. And the second area is I just don't think there's anything that's really evolved to compete with something like an airline could. And so we're talking about going the same line, but 5 times more energy efficient. And the other thing that I think has occurred, and aside from the technology being enabled by discoveries in the last 20 years, is I firmly believe this power of connectivity, and you can see it throughout time, right? You can see it from Roman roads, Spanish ships, transcontinental railroad, the airplane, the car, the internet. Every time connectivity has come together, there's been a massive amount of GDP growth that has followed. And this is just, I'll say, a 21st century solution to a 21st century challenge, which is better connection for people and goods.
When Hyperloop was first proposed, I remember them talking about, really, you're talking about sort of regional connections, but it can also be used sort of in place of airplane travel to go to Europe or to go very long distances. Is that something you're looking at in the long term?
I think if we look at the competitive landscape in 20 years, that we'll be competing in a world with autonomous vehicles, vertical takeoff and landing vehicles, and supersonic aircraft. I think supersonic aircraft will dominate that, call it long-haul trip. But where it's really exciting for us is our largest investor to date is a group called DP World Dubai Ports. Why? Because they're very interested in shipping freight. And so to give you a sense of scale, 1% by mass of things that are shipped actually represent 35% of the price and the revenue. And that's like air cargo, right? So imagine us going from Beijing to Berlin, which right now is a 7 or 8 week boat ride, doing that in 12 hours with a Hyperloop. And just for another sense of scale, they're going to spend, to improve the Silk Road, they're going to spend something like $100 billion. That's going to take the average speed on the Silk Road from 50 kilometers an hour to 70. We're talking about 800 kilometers an hour. And so like I think if they're willing to spend like that amount of money for I'll say a minor rounding error in transit time, what would they do for something that's, I'll say, transformative in time?
There's sort of an analogy for some parts of the world where you're talking about operating where the people went from not having telephones to having cell phones. And in this case, they might go from a railway system that was set up by the British in the 19th century to state-of-the-art travel in a very short time. India has very poor infrastructure for travel right now, and it's amazing to think of how they'd be the first in the world to have this tech.
Yeah, I think that's what's the most exciting thing to them. Instead of being, we just had our first son and all of his clothes are handed down from our neighbors. Like, wouldn't it be great for him to get new clothes and have like the new thing that actually is helping him become better or helping his citizens connect quite a bit faster? And I think that's the real exciting thing there, is that they have the potential to be first and not get, you're talking about building new high-speed rail, which was developed 60, 70 years ago.
Tell us a little bit, you had talked a little bit about Saudi Arabia as a potential partner. That didn't happen. Why did that not happen?
I won't say it's not happened yet. I think it's slow. I think the concern that we see from a lot of people that aren't Western regulators are, this technology is very advanced. I'm used to dealing with trains, fixing potholes, whatever it might be. How do we ultimately understand this? And they're looking for basically partners, a Western regulator to help with that, either US, Canadian, European, or anything like that. And then I think the other thing is it's exciting to be first, it's scary to be first, and there's a little bit of like, if you're first and it becomes the best idea in the world, you look like a genius. If you're first and it doesn't pan out, you're an idiot. And so I think there's a balance there.
You have talked about Dubai to Abu Dhabi, though, right? Is that still a potential corridor? I
think that's still a potential corridor. I think the economics right now on that is there's not a lot of ridership, enough ridership with that right now. But I think there's some projects within Dubai, like connecting the two airports, flying into one airport, getting on a 6-minute Hyperloop that takes you 50 minutes to another, and flying out of that means they could save a ton of money on the actual airports and the infrastructure that they're building.
How do you deal with safety issues in Hyperloop? Like, if there was a problem with a pod, you're in a vacuum there. How do you have access to the cars inside the Hyperloop?
So we've been spending a lot of time with regulators over the last 6 to 12 months. And one of the things that's really exciting is when, in that particular example, if a plane depressurizes, what happens? Oxygen masks come down, you put it on before you help someone else. Plane has to descend to 8,000 feet, takes 3 or 4 minutes. Planes don't depressurize all that much. Hyperloop won't depressurize all that much. But if it does, you can bring the tube back up in 30 seconds and be in a safe environment. So there's access
ports along?
Yep.
Okay.
Yeah.
So any part of it is removable or something like, or?
It's basically like if you're in a tunnel now, you see some of those doors about every 200 meters or so.
Okay.
You'd see something similar and you'd be able to walk out.
One of the things I like about Hyperloop is that it's electric. And it's essentially, would you say, zero emission in operation?
Yeah, so zero direct emissions. We're basically building a high power, long range electric vehicle that's taking us at speeds of an airline, but for a fraction, 5 times less the energy consumption. And
I have to stop you here, Josh. We're out of time. Thank you very much. This is Transportation of the Future, Hyperloop One from Virgin, and take a look at what they're doing. Thanks.
Thank you.